Welcome to this session. This session, you have two problems here to solve involving determinants. So copy the question. So let's solve the problem. The first question is to determine the values of x for that determinantal equation. So question 1, 2x minus 1, x plus 7, x plus 4, x and then 6, and then we have 2, and then we have x minus 1, and then we have x plus 1, and then 3. Then the value of this determinant is 0. So let's reduce this one step by step. So let's say row 1 to be row 1 minus row 2. Let's keep row 2, and let's keep row 3. So this will give us determinant of now 2x minus 1 minus x will be x minus 1. X plus 7 minus 6 is x minus plus 1. X plus 4 minus 2 is x plus 2. And then this determinant x 6 2 x minus 1 x plus 1 and then 3. So that's the first step. Remember, everything here will be equated to 0. So let's now say row 1 to be row 1 minus row 2, row 2 to be row 2, and row 3 to be row 3. Okay, so row 1 now, so we have used 2, so let's now go to 3, row 1 minus row 3. So this will give us determinant of x minus 1 minus x minus 1 is 0, x plus 1 minus x plus 1 is 0, x plus 2 minus 3 is x minus 1, and then we have x 6 2 x minus 1 x plus 1 and then 3. Remember, this will give us 0. And you see now the determinant we have is easier to calculate by cofactor method. We know the sign here is plus, sign here is minus, sign here is plus. So that shows that the determinant is x minus 1 multiplied by the sub matrix formed by x, subdeterminant formed by x 6, x minus 1, x plus 1. This will give us 0. So already x minus 1 is 0. So this is x squared plus x minus 6 into x minus 1 equals to 0. So that gives us x minus 1 into x squared plus x minus 6x plus 6 equals to 0. So x minus 1, x squared, now minus 5x plus 6 equals to 0. Now let's deal with this quadratic expression. Product is 6, sum is minus 5. Numbers, minus 2, minus 3. So we'll have x squared minus 2x minus 3x plus 6. Here we'll have x into x minus 2, x minus 2. So we have x minus 3, x minus 2. So we'll have x minus 1 into x minus 2 into x minus 3 equals to 0. So this implies x minus 1 equals to 0, or x minus 2 equals to 0, or x minus 3 equals to 0. And this means x is 1, x is 2, or x is 3. So those are the values for that given problem. And lastly, number 2, we have to show that this determinant x plus y, 5x plus 4y, 10x plus 8y, and then x, 4x, 8x, x, 2x, and 3x. We have to show that this is x power 3. That was the second problem in our two appetizers. Now, we'll say this determinant x plus y, 5x plus 4y, 10x plus 8y, x, 4x, 8x, x, 2x, and 3x. So we say, let row 1 to be row 1, let row 2 to be row 2 minus 2 row 1, and let row 3 to be row 3 minus 3 row 1. So this means this matrix would be, this determinant would be x plus y, x, and then x. So we have 5x plus 4y minus twice row 1 will be 2x minus 2y. So 5 minus 2 is 3, 4 minus 2 is 2. So we have 3x plus 2y. So that's what we have. And then 4x minus twice, this will be 2x. So we get 2x. And 2x minus 2x, this will be 0. And 10x plus 8y minus twice, minus thrice, so 1 will be 3x minus 3y. 10 minus 3 is 7. And then 8 minus 5, 8 minus 3 is 5. And then 8x minus 3x is 5x. And then 3x minus 3x is 0. So therefore now we have this determinant, and now it becomes easier to expand using the third column by cofactor method. So I'll have x determinant of 3x plus 2y, and then 2x, 7x plus 5y, and then 5x, which will be x into 5 or 15x squared plus 10xy minus 2x into 7x plus 5y. So we'll have x into 15x squared plus 10xy minus 14x squared minus 10xy. So 10xy minus 10xy gives 0. So we'll have x into 15x squared minus 14x squared, which is x times x squared, and this would be x power 3. So that is how we prove that solution. Thank you.